and maybe add some features even by doing this, and have it in a more frictionless way. So let's see what we can actually improve. But the main thing is Cardano should get more scalable, one way or the other. And so to make blockchains more scalable, there's lots of research has been done the last couple of years. And we have researchers here which have been working on this for the last 1 or 2 years, for Cardano specifically, and just also seeing, okay, the EUTXO model provides chances, and how do those scalability ideas work and translate to the EUTXO model? And there is this one notable paper, right? You might have heard this in blog posts here and there. There's this Hydra head paper, and this is the concept of Hydra heads is what we have been mostly dealing with over the last half year. So we have been researching it, or looking at it, understanding it really, and we as engineers coming into this and figuring out, okay, what is this? How can we use this? How can we put this into products? And yeah, this is what we're basically showing today, and also explaining a bit is also what we built and explored during the last half year. And we're only in the beginning, so we're just starting in creating a product out of this. So we have been exploring, trying out things, and see, okay, what is hard, what is easy, and how to basically find solutions really in this space. And yeah, I guess let's maybe just start by so what I want to also say is that this Hydra head protocol is only a start to it, right? So Hydra can be more, as I said at the beginning, it just drives growth and adoption by scaling. And this one concept of fast isomorphic state channels, like what is the title of the paper, multi-party state channels even, that's just one building block. And from there we take it onwards. And this is one of the scalability technologies applied to EUTXO, applied to Cardano, and we try to make this a reality, but also just create products, make use of it. And so that's what we're presenting today, but there's more things to come, there's more protocols, and there's not only one Hydra solution. In the end, maybe Hydra is not only one software piece of building block, it's more like a suite of things which apply to one of the use cases well, and not as good to other use cases. So there's not one thing you turn on and just Cardano is 1 million TPS. That will not happen. We will just deploy software components, we create them, and we provide them as a technology provider, maybe even as a solution provider, like IoT might be providing solutions commercially even, but mainly we will provide a foundation where every one of you can actually build upon and also create your own drive your own use cases, enable your users to do things differently and which haven't been done or haven't been able to be done before on the main chain. So this is what we see ourselves also in technology provider, and from there I guess I'll just hand it over to Matthias. He's our research liaison, the expert. And yeah, maybe just start with a head, explaining a head a bit.
Okay. So we have basically divided the schema into 2 parts, right? You have the layer 1, which is the blockchain. I'm not sure how many people here are technical developers or not, but we try to keep it simple. Right, so there are things happening on the main chain that are sort of your guarantees that whatever happened in the head is okay, right? It's secure and it's fine. And then you have the layer 2, which is a completely separate network from the layer 1. It's also a peer-to-peer network between head participants that can exchange transactions, but at a much faster rate than the main chain, right? Because they don't have the same constraints, the same limitations. And the idea is that the head itself, right, the on-chain state, goes into multiple states. It's a state machine, so to speak. So there is an initial state, a final state, an intermediate state, and a whole bunch of transition between those states. Right? So it's also by a bunch of participants, limited numbers, right? Like 10 participants, 3 participants, 100 maybe. But if you're going to run ahead with 1,000 participants, that's not really the point. Just go on the layer 1. So small number of participants initializing the head itself by posting an initial transaction on the main chain. And that initial transactions distributes a set of participation tokens to all the head participants, right? And they do so in a way that only the participants can redeem those tokens to commit funds inside the head, right? So the participation token is sort of your tickets to enter the head, right? once you have got that token, you can do a commit, right? A second transaction that is what you pledge in a way inside the head, and what are the funds you're going to use once on the layer 2. Once every participant has committed, one participant will also collect all the funds to move the state machine in the next state. And one thing has been collected. We're in this open state where the head is live. There are funds in the heads, and now any new operation and modification on those funds will happen on this, other network, that is the layer 2 network. And that layer 2 network is using the exact same ledger rules as the main network. Right? So it has the same security benefits, it has the same transaction format, the same capabilities. Participant can exchange things.
Isomorphic.
It's isomorphic, thanks. That's what isomorphic means, right? Really, it's like you have the same transactions on the layer 1 and on the layer 2. Except that you can also modify some of the parameters on layer 2, right? You can set the fees to 0, right? And then you run all the transaction costless. So you do the whole bunch of transactions, you generate new UTXO, you have like your head ledger state, and the consensus protocol on the head is much simpler than the one on the main chain, right? On the main chain we have stake pools, they get elected, and the dance. On the layer 2, it's you have a bunch of participants, everyone needs to agree, right? It's a very simplified protocol, everyone needs the signatures. If everyone says the transaction is valid, then it's valid. Since everyone is a small number of participants, that doesn't take much time, right? You want to continue?
Yeah, I can, of course, yeah. So as transactions come in layer 2, basically they drive the state in a way, and this is indicated here in the beginning. We put things into a head, make it available. This is the U0, like the U stands for UTXO set in this case, or that the 0 is like initial state, what is available in a head. And this is driven forward, right, over time, and like as transactions come in, there's certain points in time where like these snapshots are created within the head. So basically the head agrees on, oh, this is the new state, this is the new truth, and you could do this after each transaction. This is what you do right now, actually, right? So but that means whenever you have like this agreed state, this is like the U's here are the agreed state. They are even enforceable state. That means everybody in the head agreed that this one is the new truth. And this is finality, because you could take now any of these U's and close a head with it. So this is what we see here. Any point in time, any participant of this head can close the head with one of these agreed states. They say, this is now, I want to close the head with this. So they take this this U1, for example, and close the head with it. Now what happens there is like this is like it's called the nominal close or the default closing behavior, but it's really a forced close of the head. So somebody just closed the head because they decided they want to use whatever is there, maybe on the mainnet, or they have a reason for it. Basically, maybe somebody was cheating them, or they believe they got cheated, whatever. So they just closed the head. And this is where the state moves into this closing phase, and we can actually contest what's actually the truth. So we picked here in this example deliberately like an old state, right? You see there's more things happen on layer 2. And in final state, somebody else owns more or less, and so on. And the other participants can now contest this. So there is like this contestation mechanism to make sure that although anybody can close the head, the others are not cheated, right? They cannot be cheated because they have a more recent agreed state. And agreed means everybody agreed on it, and you can just contest and say there is a more recent one, and we use multi-signatures for this and some cryptography. But this is basically a contested with, and in the end we will just reach a final state where, like in a fan-out, all these UTXOs are distributed onto the main chain again. So this means everything gets available which was in the head, the same state, the same truth which was there already in U1 or UN here, is now a truth also on the main chain. This is maybe one of the interesting properties really of this off-chain. So in the optimistic case, right, where nobody cheats itself, we are very fast agreed, we make progress, right? Everybody agrees that this is the new state, and if we have it agreed, it can be way faster than on the main chain. You can have like within a second or a sub-second, or even less, depending on latency and so on. You could say, okay, the transaction is confirmed. And you know that eventually it will be true because you got a signature by everybody. And this is this nice property of how this off-chain could work. I would say we will just jump into demo, right? Because
yeah, I would just
show this as well.
Yeah, just before that, like what's maybe not obvious with all those steps is that all of that is enforced by smart contract, right? There are Plutus validators behind the scene that make sure that all your state transition on-chain are legit. And what's legit is, in the case of the head, it can be like a bit complicated, but it's basically like you have a signature from everyone agreed to move to the next state, and this way the on-chain validator doesn't really know what's happening on the layer 2. But so long as it sees something that has been approved by all the head participants, it will assume that it's the right state. And that's why we have this contestation mechanism, right? Because you can always have someone that decides to post a previous state, and from the on-chain validator, that will look valid, right? Everyone say that state was at some point valid. And that's why you can always contest between a newer state to make sure that you end up closing your head in the right state. And in a way, you don't even have to close the head, right? You could also just keep the head open for as long as you wish, and just keep things on layer 2 and only bring it to the layer 1 when we really have to use the funds in the end on the layer 1, which might not be necessary.
Yeah, so we'll just jump into a demo, which is basically going through the same life cycle, right? So we had, maybe you can keep that like initial commit, open, and close in mind, right? Because it's not on screen anymore, but we will just go through the same life cycle. And what we see here on screen now is 3 terminals. This is like a demonstrative terminal user interface we created. And each of them is connected to one of the Hydra nodes running locally on this machine. So this is it's a local cluster, and all of these are directly connected. By the way, this is a proof of concept, right? So this is really not productive production use. So we just put this together while like reading papers all day long. And but it already should basically give you an impression how this would work and how things basically relate to each other. Like a Hydra node running next to Cardano node, what does it mean and how does it interact? So we have like a client application which is connected to a Hydra node running in the background. We'll just come back to the architecture in a bit. And we have one for each of the participants. In this example, we have 3. We have one for Alice, Bob, and Carol. You see here some aliases. There you have like these are the Hydra keys of them. So it's you have 2A for Alice, for example. And here you also see that it's connected to one of the nodes, and this node is connected to the other 2. So they're all connected, and we actually can start the head, right? So here we would use like the terminal interface to just initiate a head. We just do it now. This posts a transaction onto the chain. This happened now instantly because this is an optimized chain. It's stopped, so it's really there is not a real chain in the background because we're currently integrated with Pluto still. But we actually use the same framework, the same smart contract like architecture, which is also used by all the other projects. And so we initiated a head. This means we announce who is in the head and basically who needs to commit. Now we see that Alice, Bob, and Carol need to commit. It's highlighted each terminal where we are. And if we want to commit, as we are still in here like a test environment, we can pick arbitrary UTXO. Now you usually would basically need to spend on the main chain these UTXO to put them into the head, right? They are basically then, so we can select here some UTXOs. You see it quite barely, I guess. So we can pick some outputs here, and some of them are just ADA, and some of them are with assets. And this is just to highlight that here we use a Mary ledger in the Hydra head here. And we could also, and we also use Alonso, and all the features which you have on the layer 1 are also there on layer 2 because it's just the same. It's isomorphically the same ledger. And so we did commit things from Alice and Bob. Can you commit nothing for Carol?
I did commit nothing for Bob.
Oh, good. Bob is a cool guy.
I anticipated you.
Yeah. So just commit some things, and we see that now the head is open. On the last commit, so if all the participants committed, it was collected and the head was open. And now the head is open, we see 2 addresses own funds. They're like grouped by address, and we see who owns what. And in very simple user interface, we also have like a new transaction functionality, so we can just say, okay, somebody pays somebody else. But you would actually, you could actually connect any wallet there, right? So a wallet talks to a Cardano node in like maybe some indirections in between, right? But basically, a wallet creates transactions, signs them, and sends them to the Cardano node. And this is how this exactly the same way it would work also with Cardano with a Hydra node. When the head is open, you can just also send transactions to it. I mean, they're only valid if they span things which exist in this Hydra head. But then again, right, the same architecture, the same infrastructure can be used. And this is what we do. So we actually, what do we do?
I'm sending money from Carol to, let's say, Bob.
Yeah, let's say we send something to Bob. So we select one of Carol's UTXOs. We say who to send it to. So this is a bit simplified, right? So actually you could just create any output. You could just send also people who are not in this head. Maybe a bit pointless because they would not receive before closing the head, but you could do, right? And in this simple user interface, we just take all the head participants as like a contact list and just make it a bit simple. And this highlights also a bit that Bob can be in a head without owning anything or actually committing anything to this head. He can just receive there, that's fine. Which is not true for some payment channel constructions you might have heard from. Did we send it? Yeah, it was instant,
yeah,
right?
I just sent one ADA to...
Was it instant? I guess it was instant. So it should have been like within like, yeah, a couple of milliseconds. It's local, low latency, right? But there is no block time, there's no block forging and so on. And it's a quite direct connection still. Maybe there is later on we'll have a mesh network, a bit more flexible, a bit more similar to the Cardano network, but you can see there is not this like globally spanned consensus required to do this. You see here that there's a snapshot 1 confirmed. Snapshot confirmed means like this is the new truth. It was signed by all the 3 nodes in the setup, right?
And yeah, that means that now possibly we could just choose to close the heads and bring that back on chain, right? That's like the new UTXO distribution is like that. So closing it now would be a bit pointless because to open a head you already have to make a few transactions. So you just make 1 transaction, so don't close the head right now. But you could imagine, for instance, people, institution exchanging money for like a whole day, right? They open a head in the morning, they exchange all of money, and at the end of the day they just settle the whole thing, right? Like it's happened on like card payment schemes, like Visa, MasterCard, like that's pretty much how things happen, right? They settle at the end of the day, and the next day they just reopen things and they go ahead. Or you could imagine, for instance, I don't know, an NFT auction, right? You got like 100 people that want to participate to an auction, they go into a head, they make whole payments to run this auction, and since you can run validators inside the head as well, you can have also a smart contract that is administrating this whole auction thingy inside the head. And once the auction is done, you bring the results back on the layer 1. Right? So you have saved the whole layer 1, all those transactions. So
yeah, we close it now because we want to have the full life cycle, right? So when it closed, we saw now that this is also who closed it. I'm not sure. Right? Some of them.
I'm not sure who closed it.
The contestation deadline is like 10 seconds now only, so this is quite short. This is only in this like really test environment, right, to demonstrate. For like a real chain, you would have like the contestation deadline needs to be, or the period needs to be way longer than such that everybody can actually contest. And there, the problem comes with rollbacks and like the whole real world problems come with that. So, but I want to say that this like closing, contesting, like maybe multi-hour contestation periods, even days maybe, to make sure that the chain is not rollback and not an old state is closed by accident or distributed by accident in the end. This is only the truth if you force close ahead, and there's protocol extensions which basically say, okay, if everybody agrees on this is the final state, you could just cast a vote in the head again. Hey, do you all agree that we close the head with this state? If everybody signs that, that's golden, right? That's good. And then you actually don't need to wait and multiple transactions. A single transaction is enough to close the head and distribute funds because everybody agreed on these distributions. And yeah, distributed they have been now. So the last transaction just posted on chain, which in the coordinate or in the optimal case actually, you have 1 transaction to initialize, we have 1 transaction per party each to commit, if one to collect it, but then there's maybe only 1 to distribute. There's some technical details on top of this as well. Basically, transaction sizes need to be accounted for and so on. There might be multiple transactions to distribute all the funds and so on, but there you go. Only in the beginning and in the end, you need to do main chain interaction. In between, there's nothing. You can do as many transactions as you wish for no fees if you want. And that's about the demo, right, I guess?
Yeah, we have like 5 minutes left, I guess, before it starts over. So I'm not sure how many people here are like developer kind of backgrounds. Can you help me?
Yeah, okay, some.
Because I mean, we could like discuss a bit more in detail about like the technical architecture of the Hydra nodes that we currently have, how it's built. But that's maybe only interesting if you can understand what we're talking about. So
I would, can we put the slide quickly just to show a bit, because this is our mind model at least and how things are connected.
Yeah, okay.
And then we can maybe just take it also like in little conversations outside if you want to continue, right? So
that's the
you see the log output here. Should be in, yeah, that's one. Yeah. So, because, I mean, to us it's really, the Hydra node is now in the center, like it's white boxed here a bit, right? But it's really connected to three things. It's connected to Hydra clients, so any kind of application, could be a wallet, could be a user, like a terminal user interface as we just saw here, right? But it could be also some other like application which want to send transactions through Hydra as similar as they want to send transactions through Cardano. You see it here, it's similar, right? For example, if you want to send something through Cardano, you might want to use a wallet to do this. And for Hydra, you can take this way, just the same way. This is the trick of it, right? So it's the same kind of formats which are, when the head is open, the same formats are used. There's some other additional management to be done. This is what's indicated here. Of course, the Hydra node is connected to Cardano node because it's a layer 2 network on top of layer 1, which is Cardano in this sense. So we have Cardano nodes connected to Cardano nodes over here in the bottom. This is like the robust network, nodes connected to each other in a mesh network case sense. And just similarly, on layer 2, the head is, well, not the head, the Hydra node is connected also to other Hydra nodes. So we have this layer 2 network there on top. It can be the same topology, but it must not be, right? Right now it's very simple even, right? So we have only direct connected clusters of nodes. And there's definitely one dimension where we basically do engineering effort, right?
Which is okay for like small number of participants in the end, right? We don't have the same network requirements as the Cardano nodes. And also, when you open a head with a bunch of peers, you don't necessarily trust them, right? Because you use a head, and if you're trusting people, you would just not use a blockchain in the first place. But you have some form of trust with them at least that they are running, they won't try to like DDoS you, right? So you don't have to be as protective as the Cardano node. And that's why also on the networking side, you can run much faster. You don't have to have the same defensive mechanisms in place. And the Hydra network in the end can be much more efficient than the Cardano network because of those assumptions, right? You have already agreed to all get into a head to collaborate on building this layer 2. And yeah, that's.
And if not, you can go back to the main chain, right? This is a global consensus. This is local. You just pick to work together with these other participants. And if they don't work together with you anymore, just close it off, right? You can go back to the main chain. I want to point out two things in the Hydra node. One thing is this black box, right? Is the Cardano ledger. And it's a black box by definition, so we don't want to make this different, right? It's the same ledger as it is on the Cardano node, and we just want to embed it in a way. So it's isomorphic. This is really what makes this isomorphism.
Same ledger rules, same formal verification methods that has been on it. Every update on the ledger, we can instantly bring them into the layer 2, and that's the whole point of doing that way, right? We don't need to redo the same verification on the layer 2.
You have a question there?
Yes, I have a question. Is it possible to exit the node without entirely closing it? So if one of the participants decides that, this state is good enough for me, I have to take my funds to mainnet now, then I mean one way to do is to close the channel, reopen it again for the other participant.
So you could do what we call like an incremental decommit. That is, you could choose to bring some of the funds back on the layer 1 without closing the heads. But then you would have, as a participant, to remain online also and to remain a participant of the head. Because if there are other transactions flowing in, even if you don't have any more funds, you're still part of the consensus in a way, right? Of the jury that is saying whether the transaction is valid or not. So yeah, you cannot modify the participants of the heads, while the head is started, right? So to change them, you have to close it and to open a new one. So that would be a bit like pointless in a way. If your goal is really to say, no, I'm done, I retract, you will still have to run it for the consensus at least.
Sorry.
There's one question there in the background. I just want to
another question. So, what you presented sounds like the layer 1 solution is already ready for it, right? Or with Alonso, basically everything's there on layer 1, so what's missing is the layer 2 solution, right?
Yeah, that's indeed. What's missing is us.
You're right.
Thank you for pointing it out.
We ought to be delivering now, yeah. So everything we need, the strict dependencies are there factually, right? So we have a means to actually present these validators, the contracts. We don't like to call them contracts or smart contracts, we like to call them scripts or validators. But in order to express the rules of how the Hydra head actually checks whether this is really a valid state or not, and nobody can cheat the others on layer 2, this is there, right? Alonso brought this to us, and this is why this is interesting now as well, right?
And yeah, we started like also 6 months ago, right? So we went a bit ahead of the curve. We knew exactly what was going to be in Alonso and how it's going to look like. So we sort of started the work, and now we are in this phase where we need to integrate now with the testnet, mainnet, and get the validators running ready. Right. So that's the layer 1 is as capable as it should be.
Okay, I have a question. Once the last head is closed, do we lose the whole transaction history, or is it stored somewhere?
Yeah, no, precisely. You lose it. You don't need it in the end.
And it's also per head, right? So what I want to say before as well is, right now in our proof of concept, we have like 1 head per node. So you need to bring up multiple processes, multiple network connections on if you want to have multiple heads. But of course you can have multiple heads. And I guess a natural thing to do, if you just want to get away from proof of concept, rather more like into DevNet, testnet, and mainnet, is allow multiple heads per node, because why to have only 1, right? And every head has their own state, and it's you actually would persist some of it, right? So basically, you're resilient against crashes and just can continue to communicate. And but if you close a head, I mean, there is no point in keeping that state anymore. And the history is gone. What happens in a Hydra head stays in a Hydra head.
Yeah.
Still maybe one thing to say is you can still keep proof of payment in the state channel, which might be important for you, right?
Yeah.
But if you decide to drop the transaction history, there's no need for you to keep.
I have 2 questions. Actually, one question was already partially, third one answered by this one, but. The first one is when you present this, you always say that this is the first version, which is understandable. You probably have, or researchers, thousands of ideas how to improve this. But what I wanted to know is that the first version that we would be able to expect one day, no timelines, what kind of use cases and features will it allow us, and what kind of use cases and feature will it not yet allow us, because we'll be missing in that first.
It's a tricky question. But what we already can say that the Hydra head makes for a good foundation. It's a good building block to extend and make like these crazy ideas we have, right? As you say, you're right. There's crazy ideas in the space and crazy researchers creating more crazy ideas all the time. But what we think is like a multi-party state channel, which is using the same transaction format in the layer 1 as in the layer 2, provides a good foundation, and we can create this in a way it can be used on the mainnet. So what use cases does it drive well? So if you would ask me personally, this is no official statement right now, if you would have a use case where like a smallish number group of actors would do business in a uniform way, like always forth and back in a rapid way, that would fit quite well to this scenario. What would not fit quite well is anybody paying somebody else. They have no connection at all. It's just random, right? Mm-hmm. You just care now. Today I want to pay this one other guy, and you will never pay or basically transact with them ever again. Then it does not make sense to go to the effort just to create this channel and so on. But there is, of course, works in how to basically interconnecting these heads, because the limitation there naturally is if it's only like a small number of people, you cannot fit everybody in this one head, right? So you might have multiple heads, and basically if you have multiple heads, I mean this is fragmented, how you would basically be in the right head and so on, and bridging heads and creating the reach and interconnecting heads, and so this is the crazy ideas you figured.
Okay, and the second one is related to replication, synchronous or asynchronous. So once you open the state channel, will the nodes, which are these trusted nodes, I assume stateful operators, at least that's what Charles has been saying all the time, that these will be stateful operators.
I will come back to that.
Okay, maybe not necessarily stateful operators, please come back to this as well, but will these people be replicating between each other? So let's say that one of those nodes goes offline because it has an outage. So that means that's, and will you do synchronous or asynchronous replication if you're gonna do any replication?
So the thing is, like for head to run, you need to be online all the time, right? Because you need the nodes to be responsive. And the reason why you need that is because if someone closes, you need to be able to contest, right? So if you're not online, you're taking the risk of not being able to contest. And also, the protocol we just stole. Right?
I'm not talking about outage, just so that you are aware. I'm not talking about scenario that they maliciously go offline.
Yeah,
I'm talking about just their boxes explode or something.
From your other peers, there is no way to differentiate someone who is purposely offline and someone who is offline because of an outage.
Okay.
So it's really a decision of the head participants. If you send a transaction and if you don't get any acknowledgement for one of your peers for like, I don't know, 10 minutes, right? Then it's up to you to decide whether you want to close the head, right? You maybe see that as an adversarial behavior and you just decide to close, or you say maybe just it's just offline. I'm gonna wait. So it's really a decision you will make as a head operator in a way, right? You can imagine like a monitoring system. You get another stack transaction, you don't get confirmed.
Oh,
So running out of time, we'll be outside, so you can just hit up with questions. The code is on GitHub. There's some intro, readme tutorials. Try it out. You can do the demos while you're to yourself. We would love your feedback. GitHub issues over on Discord. There's a channel, Ask Hydra, in the Discord technical community, and Stack Exchange as well, right? So ask questions there to get points, internet points.
So yeah, and just like
thank you.